Greetings and welcome, friends. We've been talking about common logarithms, as well as the characteristic and the mantissa of the evaluated part of a logarithm. So here we go. It says if log of 6500 is 3.8129, find each number. So what I want to point out, first of all, regarding the log of 6,500, that's the same as the log of 6.5 times 10 to the third, right? Which would equal log of 6.5 plus log of 10 to the third. The log of this part here, log of 10 to the third is equal to 3, and the log of 6.5 would have been the 0.8129. So, this is the mantissa, and this is the characteristic. So, if I want to evaluate what the mantissa of log of 0.065 is, we could rewrite this in psi naught. So this would be log of 6.5 times 10 to the, and this is negative 1, 2, negative dose. And the log of a product is equal to the sum of two logs.
Cheers!
Bless you.
Thanks.
You're welcome, friend. And log of 6.5, well, we happen to already know what that is. That's 0.8129. Plus a negative 2, because 10 to the, what is 10 to the negative 2? That's right, negative 2. And so here you can see that the mantissa is in fact the same as it was for the previous. And the characteristic, if we were interested, characteristic is that. Now, let's take a look at this next problem. So, the mantissa for basically multiples of 10 of the same number ends up being the same each time, right? So even if I had 0.00000065, the mantissa I would anticipate would be the same, but the characteristic, however, would have changed, right? And one of our prerequisites for the mantissa was that it was a positive value. Here's question 19. The directions for this said, use a scientific calculator to find a logarithm for each number rounded to 4 decimal places. Then state the mantissa and the characteristic. So if I hit log of 900.4, I end up getting that log of 900.4 is equal to about 2.9544. Now, what is the base of this log? 10. Correct again. That's a good question. Yeah, the 10 is invisible. Good question, right? So it's implied there every time you don't write a base. So it's base 10. So if I wanted to break this apart, I actually could. This would be the same as 0.9544 plus 2. And because this is already positive, I don't have to somehow rewrite it so that the mantissa is positive. So here's my mantissa. And this is the characteristic. And if we ended up with the log of a negative value, that's when, if you write it in scientific notation, not unlike this previous step here, right? Or the log of a decimal less than 1, that scientific notation will result in giving you your negative characteristic and the positive mantissa.
You forgot the CI characteristic.
Which characteristic? Character.
It's D.
Oh, this C, right there. Aha! I like it. That's a slightly different yellow, but I'll tolerate it. I'll increase my tolerance of shades of yellow. So, one last question. Now, it says, use a scientific calculator to find the anti-logarithm for each logarithm rounded to 4 decimal places. So what I just want to point out real quick with this one is that anti-log of 2.1495. Now remember that the log is an inverse of an exponential function. So the inverse of a logarithm is the inverse of an exponential function, and therefore is an exponential function. So this just means 10 to the 2.1495. That's dyslexified there. And if I hit second log on a calculator, typically the 10 to the, right, a base 10 exponentiation is by default what we get. So 2.1495, and I get 141.0912. Right, so not too bad. Thanks for watching, friends.
Have a lovely day.
Oh.